The origin of this long-lived storm has baffled astronomers. But now, science may be on the verge of unraveling its stormy secrets. The Hubble Space Telescope recently snapped images of 3 smaller storms on Jupiter called white spots. Within 3 years, the 3 white spots merged to form one Earth-sized storm. Then, the unexpected happened.
Over the course of only about a week, the storm turned from white to bright red. It's now known as Oval BA, or sometimes Red Junior. Why it turned red and exactly how that happened is still a mystery.
Astronomers now suspect a similar merger may have also created the Great Red Spot. And like Red Junior, the ferocious storm may have originally been white. But as its speed grew faster, it began dredging up material from deep in Jupiter's atmosphere. One of the compounds could actually be a form of sulfur.
We don't fully understand why the red spot has its characteristic brick red color, but probably there are chemical compounds which are reacting with the sunlight and are giving it this color.
Astronomers have been closely monitoring the Great Red Spot. And in the last decade, they have detected an astonishing change.
We've been watching the Great Red Spot shrink and actually become rounder for some time now. Who knows if it's going to persist for another 400 years or maybe disappear entirely.
The Great Red Spot is by far the biggest storm in our solar system. But after leaving Jupiter, we head about 200 million miles in the direction of the Sun and have a close encounter with another barely believable wonder. Number 4. The Asteroid Belt. Scientists want to know more about the origin of this cosmic junkyard of wayward debris, which is left over from the formation of the solar system.
For a long time, we thought that maybe there had been a planet there that got pulverized and we were just seeing the debris of some major catastrophe. But we pretty much now realize that a planet never was able to form there. The gravitational pull from Jupiter and the other planets just made it impossible for material to coalesce into a planet.
We traverse through 100 million miles of rocks, some as small as several feet, others bigger than cities. The belt probably contains millions of rocky pieces. Yet if all the asteroids were condensed into one boulder, it would be smaller than our moon.
We can start to learn more about the history of our solar system by studying the small bodies in our solar system, the asteroids. We'd like to know how they moved around, how are they affected by the giant planets, and what is their ultimate fate? What will happen to them?
Popular movies have portrayed the asteroid belt as a cosmic obstacle course, a place where spaceships dodge enormous boulders that constantly collide and jostle for position before hurtling down from space to destroy planet Earth. But has Hollywood gotten it wrong? How congested is the asteroid belt? That's what one viewer wanted to ask the universe. So, Joel T. from Kansas City, Missouri texted us. Have movies accurately represented what the asteroid belt actually looks like?
Thanks for the question, Joel. I know this is a bit shocking, but the asteroid belt hasn't always been portrayed terribly accurately in most blockbuster movies. If you were orbiting an asteroid inside our solar system's asteroid belt, you wouldn't be able to see big cratered surfaces of other asteroids lying right next to you. In fact, they probably look just like distant points of light. That's because the average separations between most asteroids in the asteroid belt are much larger than their actual sizes, so they really just look like dots.
In fact, An average distance between two asteroids can be 1 million miles. However, among this spacious sea of odd-shaped rocks exists a round ball. Ceres is the biggest asteroid in the solar system. The awesome 600-mile-wide rock contains a fourth of the entire mass of the asteroid belt.
Most asteroids in the asteroid belt are lumpy-shaped, kind of like potatoes. But Ceres is different. It's actually big enough to have enough mass, to have enough gravity, to crush itself into a round shape.
Because of its spherical shape, Ceres was upgraded. Scientists recently listed it as a dwarf planet, the same designation given to Pluto.
The modern view of Ceres is that it's not big enough to be called a genuine planet, but it is big enough for it to have formed a roughly spherical shape, but not big enough to be a true planet.
This fourth wonder not only holds unique artifacts from the formation of our solar system, it also harbors potential weapons of mass destruction. Many asteroids have escaped the confines of the asteroid belt. And at any moment, one of these rogue space rocks could repeat history. And no one will live to talk about it. So far, our journey through the 7 wonders of the solar system has taken us to the geysers of Enceladus, the rings of Saturn, and the Great Red Spot on Jupiter. Now, we continue to travel through the fourth of our wonders, the asteroid belt. This band of leftover debris has even made it to the big screen. And the rocks Hollywood is obsessed with the most are those that escape the asteroid belt and head for planet Earth. Near-Earth objects, or NEOs, are cosmic rocks like asteroids or comets, which strike Earth almost every day.
We're really very interested in near-Earth objects, objects that pass across the orbit of the Earth around the Sun, because occasionally they can and do collide with the Earth. And if they're big enough, they can cause vast destruction here on Earth.
On April 14th, 2010, cameras caught sight of a 3-foot fiery asteroid streaming over the Midwestern United States. Fortunately, the cosmic rock broke into tiny pieces before hitting the ground. But in the past, large asteroid impacts have created gigantic craters and even triggered mass extinction events, like the Chicxulub asteroid that killed off the dinosaurs.
Over the last billions of years, Earth has been hit many times by asteroids of various sizes. The impact that occurred roughly 65 million years ago that perhaps wiped out the dinosaurs was an example of something that was about 6 miles across, slammed into what is now Mexico, and caused huge global ramifications for the Earth.
A number of new space surveys are currently tracking all near-Earth objects that are large enough to destroy a modern city, or even worse, ignite a global catastrophe.
We know of most of the objects that are larger than a mile that can intersect the Earth's orbit, and so the effort now is going into finding these sort of stadium-sized objects that, while not completely devastating to the entire Earth, would be a huge deal if they hit Earth.
As we leave behind the asteroid belt, we chart a course to the next of our 7 wonders, Olympus Mons, the largest volcano in the solar system. As we approach the planet Mars, we immediately catch sight of this mammoth mountain.
The base of it is about almost 350 miles across. That's as though the base of the mountain were from Los Angeles to San Francisco. So even though it's so high, the slope is very gradual. You would barely know you were climbing a mountain. It's not like a steep volcano. It's a smooth, low slope, but it just goes on forever.
Olympus Mons is located in the Tharsis Bulge, a region on the red planet that's home to other massive volcanoes. If you climb the 13 miles to its summit, you could take in a view of the very edge of the Martian atmosphere.
Olympus Mons is several times higher than the highest mountains on Earth, and its base is hundreds of miles across. And it's been formed over the last billions of years by eruption after eruption after eruption, which has slowly surfaced it with successive layers of lava.
100 million years ago, hot lava rivers poured down from its peak to cover millions of square miles of the red planet. Today, Olympus Mons is 100 times the volume of Earth's largest volcano, Mauna Loa, located on the big island of Hawaii.
Olympus Mons got so much larger than anything here for, well, a number of reasons. One is certainly it was just a lot of volcanic activity. A second is that Mars's gravity is much lower. You weigh a lot less on Mars. So as the mountain built up, it didn't compact back down. It was able to build up to a pretty huge volcano without collapsing.
The third, and perhaps most important reason why Olympus Mons is so huge, is that Mars doesn't have plate tectonics, the movement of crustal plates that rest on top of the molten interior of bodies, such as Earth.
Olympus Mons grew to such a big size because of the lack of tectonic motions on Mars. The hot spot from which the lava, the magma, emerged remained at one location, allowing more and more material to build up and create a super mountain, a super volcano.
Mars is now presumed to be geologically inactive. But is the volcanic beast really dead, or merely a sleeping giant? The European Space Agency's Mars Express mission recently captured the highest resolution images ever taken of the planet's lava flows. Some flows date back 115 million years, but others are only 2 million years old. And on geologic timescales, that's very recent, which suggests there still may be some volcanic activity.
If we look at the surface of Olympus Mons, we see especially that there are lava flows which have very few craters on them. And so we know that those lava flows are perhaps 10, 20 million years old at the oldest. But the eruptive activity has been going on until the relatively recent past, if not right up until the present day.
Olympus Mons may have once produced vast amounts of lava, but its hellish heat pales in comparison to the current temperatures of number 2 on our countdown of the 7 incredible wonders of our solar system. This may look like a ball of flames, but its surface is an ocean of 10,000-degree plasma with waves, winds, and massive eruptions as explosive as 1 billion tons of TNT. Our next wonder of the solar system has been Earth's best friend and foe. It's bathed our planet with heat and energy.